Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. This one slip lost more marks than any other on last year's papers. A student converted an exact surd to a decimal in the middle of a solution, and the examiner couldn't award the final accuracy mark. Sound familiar? You need to hear this episode.
That's me every time. I panic and put 1.414 in, and then I lose the final mark, even if the working looked okay.
Promise and approach. In the next 10 minutes, I'll show you how to simplify surds so they stay exact, how to convert between fractional indices and surds without guesswork, and a calm, reproducible method to rationalise denominators. I'll also show the exact layout examiners reward, so you can collect method marks, even if you don't finish. Let's work through this step by step.
The concept. Start simple. First rule, keep exact forms. That means no decimals until after you've written your final exact answer, if the question asks for an exact form. Example 1. Simplify root 50. Many students say, it's about 7, and move on. Wrong move for higher tier exact work. Instead, factor 50 as 25 times 2. 25 is a perfect square, so root 50 equals root 25 times 2 equals root 25 times root 2 equals 5 root 2. We write 5 root 2, and that is the exact simplified surd.
So the step is look for perfect square factors, pull them out, and keep the smallest surd inside. Got it?
Exactly. Now, indices, the laws you already know. A to the m times a to the n equals a to the m plus n, and a to the m to the n equals a to the mn. Why these work? Indices count repeated multiplication. If you multiply a squared by a cubed, you multiply the base a 5 times in total, so a to the 2 plus 3. Fractional indices link to roots. A to the half equals square root of a to the third equals cube root of a. Combine them. A to the 3 halves equals a to the 1 plus a half equals a times the square root of a. Practice saying that out loud. 3 halves means multiply the full power and then take the square root. It helps memory.
Negative powers. A to the minus 1 is 1 over a. It's simply the reciprocal. So a to the minus 3 over 2 equals 1 divided by a to the 3 over 2. Keep the exact structure. Don't swap to decimals.
Now, rationalisation, the part that flusters students. Take this example. Simplify 1 over root 2 plus 1. The trick, multiply numerator and denominator by the conjugate of the denominator. The conjugate of root 2 plus 1 is root 2 minus 1. So multiply top and bottom by root 2 minus 1. Watch the algebra. Numerator becomes root 2 minus 1. Denominator becomes root 2 plus 1 times root 2 minus 1, which is root 2 squared minus 1 squared, the difference of squares. That equals 2 minus 1 equals 1, so the whole fraction simplifies to root 2 minus 1.
That's so neat. Multiply by the conjugate, use difference of squares, and the denominator collapses. No messy decimals.
2 important checks as you do that. First, sign management. Make sure you write the minus in the conjugate. Second, simplify the denominator carefully. Expand if needed, but look out for perfect square subtraction, which often cancels down to an integer. That one small sign mistake is the single careless move that costs most candidates a mark.
From a marking perspective, we award marks for method, not for mental arithmetic. Show the conjugate multiplication or the key algebraic step, and you claim the method mark.
Good point. Which brings us neatly to exam technique. We'll dissect a typical 4-mark question. Simplify and give your answer in exact form. 1 over the square root of 2 plus 1. How are marks allocated? Mark breakdown we often see. M1 for writing multiply numerator and denominator by the conjugate. M1 for correct expansion leading to a simplified denominator, and A1 for the final exact answer. If you stop after writing the conjugate multiplication but don't simplify it fully, you usually still keep that first M1. Write it down. Write it down, don't just think it.
So, even if I'm not confident finishing the algebra, I should show the step times by root 2 minus 1 over root 2 minus 1, and that can save me a mark.
Exactly. Common marking traps. 1. Swapping signs incorrectly in the conjugate. 2. Cancelling terms across addition in the denominator incorrectly. 3. Switching to decimals mid-solution, which loses the final A1 when exact form is asked. Layout tip. Write each line as a distinct step. For a 4-mark question, you might have 4 clear lines. Write the original fraction, show the multiplication by conjugate, expand denominator, give simplified exact answer. That visual structure helps the examiner award marks quickly.
Quick win. A 10-second checklist you can run in the exam every time you see surds or indices. 1. Keep exact form. 2. Look for perfect square factors. 3. If denominator has a sum with a surd, multiply by the conjugate. 4. Watch signs. 5. Substitute an approximate decimal to check if time allows. Here's a one-line rationalisation template to memorise. Multiply top and bottom by a minus b when denominator is a plus b. Denominator becomes a squared minus b squared. Say it once before the paper and you'll recall it under pressure.
I can do a one-line template. Quick win noted. Multiply by conjugate and check signs.
Practice prompt. Try this now. Simplify 3 over root 3 plus root 6 and give your answer in exact form. Pause the podcast if you want to try it on paper. If you work it through, here's how you check under timed conditions. Multiply numerator and denominator by the conjugate, root 3 minus root 6, expand the denominator as difference of squares, simplify, and finally rationalise any common factor. If you have time, approximate your final exact answer with a calculator to sanity check it. The decimal should match the original fraction to 2 or 3 dp.
If I'm a parent or teacher listening, suggested follow-up, give 3 similar questions, 1 easy, 1 medium, and 1 stretch, and mark for method rather than final decimal answers. Make students stop and write the conjugate step every time until it becomes muscle memory.
Before we finish, a tiny checklist you can shout in the exam. Exact, factors, conjugate, signs, check. That 5-word prompt catches most careless errors. Let that sink in.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.